Hello and welcome to Functions, the series where we explore the various topics that are related to functions, one of the most fundamental things in mathematics. However, in this playlist, we won't be going over the very basics of functions. Before diving into it though, first and foremost, I want to thank all the nice people that support this channel by liking and subscribing. It helps massively so I can keep making more playlists and videos for you guys to enjoy. Now, at this point, you should already know what functions are, what is an input and output, some of the very basics of domain and range, where domain is the possible x values and the range are the possible y values. You also should know some of the basics of graphing a function on a Cartesian plane. Cartesian plane is just a fancy name for the xy plane that we use almost every single day. However, for the introduction, I will show just some basics as a refresher so that you are ready for further videos. We begin with the definition of a function, which is a correspondence or mapping between two sets x and y, where each element of the set x corresponds to exactly one element of the set y. Now, what does this mean? You might have heard something about the vertical line test. If I grab a function on our Cartesian plane, and then I draw a vertical line anywhere on the plane, it only crosses our function at one specific point. That means it is a function, which is what the definition states. Each element of set x corresponds to exactly one element in the set y. So, just as a quick example, the function y is equal to 2x plus 1 is a linear function, which means it is just a straight line as such. And it is a function because if I draw a vertical line anywhere on our Cartesian plane, even when moving it around, it only crosses our function at one specific point. So now let's explore a counterexample. In this example, we're going to write x squared plus y squared is equal to 1. However, this here represents a set of order pairs x and y on a circle with radius 1. If we were to graph this expression, here on the graph is what I would get. However, this does not pass the vertical line test because if I draw it anywhere, almost, it will cross the graph at two different points, which means this expression here is not a function. However, we can also solve this in a non-graphical way, but in an analytical way. We know that functions are always expressed as y equals to something in terms of x. So if I were to do that to our expression, what I would get is y is equal to plus minus the square root of 1 minus x squared. And here you might notice that if I plug any value of x between -1 and 1, this expression will produce two different y values. Specifically, one would be positive and the other one would be negative. So that means this equation right here does not represent a function. So now that we know what a function is, let's speak shortly about the notation because there are several. Of course, the most popular and widely used notation is f of x is equal to, let's just say for the sake of our example, it's going to be equal to x squared. So that just means we plug in a value of x and we're going to get x squared as our output. Writing it in a more straightforward way would be just y is equal to x squared. However, sometimes functions might also be written in this form: f and then x with a base arrow x squared. What this means is that every single x value is getting mapped to x squared. So these notations can be used interchangeably, however, they all mean the same thing, our function x squared. Moving on, let's speak about types of functions because there are definitely several of them which we will cover in this series. Starting from the most basic one is linear functions. Linear functions are given in the form of y is equal to mx plus b. Next in line would be quadratic functions, given in the form of ax squared plus bx and plus c. Moving forward, we have something called rational functions, where y is given by f of x divided by g of x. Then we have radical functions, which are given by y is equal to square root of f of x. And finally, we have a very broad field called polynomials. They are in the form of an x to the power of n plus an minus 1 times x to the power of n minus 1. This will continue until the last terms a1x plus a0. However, please do note that linear functions and quadratic functions are also considered polynomials. However, they have their own specific characteristics, which is why we pull them out. Now, each type has its own features with regards to domain, range, graphing, format, and solving. Now, I can tell you immediately that for linear functions, there is unfortunately nothing special. Both domain and range is simply all real numbers. So we write x and y both belong in the real number field. Now the letter m denotes the slope of our line. You might know that it can be calculated using two given points and with the formula y2 minus y1 divided by x2 minus x1. In a more simple way, we can write it as the change in y divided by the change in x. Now, the graph is always just going to be a straight line going in this direction if our slope is positive, and going in this direction if our slope is negative. Now, the letter B just represents the vertical shift from the origin. Some others also like to call it the y-intercept. The y-intercept is simply where the graph crosses the y-axis. And of course, there also exists an x-intercept where the graph crosses the x-axis, and we find those while equating the function to 0. So I think that is enough for now. Starting from the next video, we will begin exploring quadratic functions. So I hope to see you there and have a nice day. Bye.